I'm going to start making slides probably. Sorry, side thought. So the number one at the top of this has the cost of 2 tacos and a drink is $3.07. The cost of 3 tacos and a drink is $3.86. How much does a drink cost? So did anybody come up with the 2 equations that we would use for this here? Yes. Yeah, so you could use T or you could use T and D or X and Y. Either one works because we're just talking about 2 variables. And these here would be the 2 equations. So that's our 2 equations for the first one. Did anybody get the 2 equations for question number 2? Josh bought 800 plastic whistles to give away to kids at the street fair. Some of the whistles were small and cost 50 cents each. The large whistles cost 75 cents each. In total, he spent $550 on the whistles. How many of the small whistles did he buy? Yes. And for both of these here, I would label in the word problem like which variable you're talking about is which. So some of the whistles were small and cost 50 cents. I might put an X over small if I'm signifying it as it being X. The larger whistles cost 50 cents, so I might draw a Y if I'm writing them down on a paper copy of the test. If it's a digital copy and they just give you scrap paper, I might jot down somewhere X small, Y large, just so I know which one it is and I don't have to delve back into the problem once I finish solving to look back and say, okay, 0.5, which one's 0.5? Okay. I'd rather have it written down so I can grab it a little bit quicker than having to delve back into the problem. Last one. Sherry bought 20 apples at the grocery store. Those kind of apples were 80 cents each, and Granny Smith apples were 65 cents each. Altogether, the apples cost $14.95. How many Granny Smith apples did she buy? So what are our 2 equations? Yep.
Courtney, Sequoia, come to the office. Courtney, come to the office.
So you're all able to get something like this here? One of these 3 equations?
What's the third equation box?
Altogether, how many apples did she buy? Or how many Granny Smith? I don't know what the third one's for. They probably have a reason for it, but really we only need the 2. You can just leave it blank. I mean, because really once we have those 2, we're done. Really I use, because when I was filling this out, I put both equations in one box and then solved it in the other. But it wasn't asking us to solve any of these at this point. Now, if we look at the next page, I think page 41 for y'all, it actually asks us to solve them. So we found the equations, now we're going to solve it. So this here is our first set of equations. The cost of 2 tacos and a drink is $3.07. The cost of 3 tacos and a drink is $3.86. How much does a drink cost? Well, unfortunately, we can't really plug it in and tell what the answer would be because, well, we don't have the cost of tacos. Because if we knew what the cost of a taco was, then we could actually plug both sets of numbers in and solve. So we could try canceling out T, or what we could do is go over to the graphing calculator and say second matrix, edit, and these here would be 2 by 3, and we can go 2, 1, 3.07, 3, 1, 3.86. Second quit. Second matrix. Math and find RREF. Second matrix A. So we said the second variable was the drinks, and drinks would be what? 79 cents or $1.49. Mm-hmm. Yep. So it should be $1.49. So the answer choice is C. Well, number 2 and 3, we can do the exact same thing on them, can't we? Yeah, so we could go second matrix, edit matrix A, 2 by 3, and say 0.5, 0.75, and then 550, 1, 1, 800. And if you have those flipped, that's perfectly fine. Because it doesn't matter if we have the 11800 on top or the 11800 on bottom. Either one works. At this point, we can go second quit. And if I've typed one in before, we can go on and pull it back down and hit enter. And it asks for the number of small whistles. How many small whistles did he get? 200. So 200 would be the correct answer.
So why did he get 200 instead of 600?
600 would be the large whistles. Because, make sure, because 0.5 is the small whistles.
Okay.
Yeah, so it's almost how many of the small whistles and large whistles did he buy? And that constraint combined with the fact that he spent $550 and 800 whistles. So this is the setup that would give us those two constraints. Because with that 5 cents a whistle, at 5 cents a whistle, so for 200 of them, that would cost him $100. And at 0.75, well, it'd be $450. So that's how it worked out with those numbers. Any other questions on this here? And we can look at the last one, and it would just be doing the same thing. Second matrix, over to edit, 2 by 3. This time we'll have 0.8, 0.65, and 14.95. 1, 1, 20. Then we go second. Well, second quit, second matrix over. I mean, I could have picked it again. RREF, second matrix A. So we have 13 and 7. Now I picked X to be the Barron. I don't know. And then the Granny Smith apples was Y. So the number of Granny Smith apples was 7. So the correct answer is A. Any questions on this here? Do we feel kind of comfortable with these here? Starting to get them figuring out how we set these up? Yes. Let's look at 3.32. 3.32. Kelly bought 4 shirts and 3 skirts for her doll and paid $11.40 total. After she did a doll fashion show for her best friend, Kathleen wanted to know how much one of the skirts cost. Kelly remembered that each skirt cost 30 more cents than each shirt. How much did one skirt cost? So I labeled shirts as X, so we can say 4X plus 3Y is equal to, bless you, 11.40. So that gave us one equation, but she said what else? Remember that each, okay, so how can I write that? Y is equal to what?
X times 0.3
Plus 0.3, because each one costs 30 cents more, so each skirt is going to be whatever the cost of the shirt is plus 0.3. Now, the way this is set up, we could use substitution, because I could substitute this whole thing in for y, solve for the value of y, and then plug that value in, or solve for the value of x, and then go backwards and solve for the value of y. At this point here, we've been using a lot of matrix or using systems, augmented matrices to solve, yes? Well, there's nothing saying we can't turn that into one. Yes. So it actually doesn't tell us it more than, yeah, it just tells us it's 30 cents more than it. It'd be nice if it did, then make this a whole lot easier. Yeah. What we could do is we could subtract x from both sides and say y minus x. Well, it'd be, because if I want to keep the variables the same, negative x plus y equals 0.3. Since x is first on the other equation, I need x first on this one. Negative x plus y equals 0.3. Because then we can pull the calculator up and go second. Trash that. And go second matrix. Apparently I was writing. And go second, second matrix. Go over to edit, 2 by 3. Then we could say 4 for x, 3 for y, and 11.4 for the variable. Now the other one, well, we had negative x, we had 1y, and we had 0.3. Because those were our 3 spots for the second equation, yes? Second quit, second matrix, over to math and find our REF, second matrix A, enter. So we said the shirt was X, so it's 1.5. And the skirts are $1.8 each. So the skirt would be $1.08. This is answer choice E. Any questions on this here? We good with this here? Okay. Let's definitely look at the next one. Bobby opened a bag of candy and counted how many pieces were in the bag. The bag contained 68 pieces total. So that'll be useful information. So there were 68 pieces of orange, lime, and cherry candies inside in total. He separated them by flavors and found that there were 2 more orange than lime and 4 more cherry than orange. How many cherry candies were in the bag? So I went and just as they appeared, X, Y, Z. I put orange as X, lime as Y, and Z as cherry. I just wrote it over the top because normally we use X, Y, and Z. So I have those there. So what would be one equation that we know for sure? Well, I know that all three should add together to be 68, yes? Okay. So that deals with that part. So orange is X, lime is Y, and cherry is Z. So let's see what else it tells us. He separated them by flavors and found that there were 2 more orange than lime. Well, orange is our X, yes? So X is equal to what?
So X is equal to Y plus 2.
X is equal to Y plus 2. Because the number of orange, or he found that there were 2 more orange than lime. So whatever lime is we have to add 2 to get to orange. And cherry is 4 more than orange. So Z is equal to X plus 4. So we are just wanting to know the number of cherry, but we need all 3 equations. Now we can use substitution if we wanted to and try to eliminate out X and Y with these equations, because this here is a 3-variable system of equation, because we have X, Y, and Z. But couldn't we do these with matrices also? We just need to get X and Y on the same side, or X, Y, and Z on the same side, and anything that is a number without a variable on the other. So there's, oh, he's going to move over here. And so is this one. I just need to get these equations so the variables are on one side and the numbers are on the other. So here I would minus Y from both sides, which will tell me that I have X minus Y is equal to 2. Here I would subtract X, and I would have negative X plus Z is equal to 4. So we'd have these 2 equations here. Now when we write the augmented matrix for these, well, we can go on and use the top one. 1 for X, 1 for Y, 1 for Z is, yep. Because we needed to get X and Y on the same, X, Y, and Z on the same side. So for the second equation, we had to subtract X from both sides, which would make it negative. I'll pick this one next. X minus Y is equal to 2. Well, X is 1, Y is negative 1, Z is what? 0, and then we would have 2. And for our last equation, X is negative 1, Y is, so Z is 1, and our number is 4. So we can use this matrix here to solve. So I can pull up the graphing calculator and go second, well, try this again. I can go second matrix over to edit. Now I don't have a 2 by 3 anymore, I have a 3 by 4. And we would have 1, 1, 1, 68. And the next one, I believe we said 1, enter, negative 1, enter, 0, enter, 2. Then we had negative 1, enter, 0, enter, 1, enter, 4. Y'all have something similar to this here. Some of the rows might be flipped because you can have them in any order. And then we go second quit. Go up to RREF, hit enter, enter, and we get this here. Now we said Z, the third one was cherries. So the one with that is 26. So the number of cherries would be 26. Yes. So when we put them in, we put x first, yes? So x is first, y, and then, so x, y, and then z is the order of the variables we put, yes? So what this is telling me across the top is, this first one tells me I have x plus 0y plus 0z is equal to 22. The next one is 0x plus y plus 0z is equal to 20. And the bottom one is 0x plus 0y plus z is equal to 26. Well, in the top row, y and z are gone, just x is equal to 22. The middle one, everything but y, and the last one is everything but z. It's those diagonal ones. So that's also why when we plug these in, we want all the x variables or all the same variables to be lined up across all the equations. So when everything's said and done, it will line up like this. Any other questions? Because it is possible to use these equations to solve it. But really the first thing I would have to do is get this equation in terms of x by subtracting 2 from both sides and say y is equal to, let's see here. Yeah, x minus 2. So I could plug that in to the original equation, say x plus x minus 2 plus z equals 68. So I've taken it from 3 variables to 2. Over here, I would need to get this in terms of z, because again, we want to know the number of cherries, and have it as z minus 4, so that I can replace every x with z minus 4. So we'd have z minus 4 plus z minus 4 minus 2 plus z equals 68. I have 1, 2, 3 z's. Negative 4 minus 4 is negative 8, 9, 10. We can add 10 to both sides. 3z is equal to 78. Divide both sides by 3. Z is equal to 2, 6. But I have a feeling for the most part it's going to be harder to figure out that and get those variables lined up. It's going to take you more time to try to figure it through that way than it is to get it set up as a system, x, y, z on the same side, and plug it in, than trying to do it this way here. Any questions on this here? Any questions on this here? We'll look at a few more, and then that will be it for today. The sum of the real numbers x and y is 15. Their difference is 3. What is the value of xy? So if I say the sum of the real numbers xy is 15, what are we saying? X plus y is, and their difference is 3. So what are we talking about difference? Would be? So x minus y is 3, yes? Now this one here, do we already have a variables that are the same? Yes, we could set this up as a system, or set it up as an augmented matrix and plug it into the calculator and do RREF. But if I add this and actually solved it by elimination, and I'm adding because the y values are opposite, one's positive, one's negative. We could have subtracted and done the same thing. X plus x is 2x. Y plus negative y, or y minus y, is 0. And 15 plus 3 is 18, yes? Divide both sides by 2, and I get x is equal to 9, yes? Well, unless y is a fraction or 1, A, B, and C are probably not going to be it. Would y'all agree with that? Because we're multiplying x and y together, it has to be a product. Well, is 15 a product of, can I multiply 9 by a number to get 15? So what's the only real possible one? 54. Well, we're saying that 9 plus y is 15. Minus 9y is equal to 6. What is 9 times 6?
Well, it says the difference is 3.
Yep.
You automatically know it's number 12.
Yep. So it can't be anything bigger than 9. So we're stuck with that, yeah. Exactly. And it's not negative, so it can't be bigger. So that's it. Questions on this here? Not too bad. Yep, so that's what that one is. Okay. Let's look at number 8. I'm skipping a few of the ones that I selected, but I want to look at number 8. A vending machine sells chips for 50 cents each and candy bars for $1. If Jim spent $5.50 on snacks in the machine over the course of a week, how many candy bars did he buy? So what are our equations we can set up? Okay, so x. Well, they gave us some dollar values, didn't they? So we know what? 0.5 x would be our chips, and then what? So 1y equals 5.50. Do we have anything else?
I have a question.
Yes.
I was thinking it'd be 5, but that's not even an answer choice. Because if it's $1 per candy bar, can you just buy 5 and we'll take a chips?
So we could have 1 comma 5, yes? Well, I could have 4 candy bars and then what? 3. That I could have 3.
So there's not enough given information.
Because are we told anything else besides that? No, because since we have 2 variables, we need how many equations? 2. We don't have enough. Is any of these points will hold true, will make this statement true? We don't know what it is. There's not enough information given. So those sometimes will be the correct answers. Just because they put it there doesn't necessarily mean it will always work out that way. I'm going to go on and let y'all do the assignment. There were more that I had selected out, but I want to give y'all some time in here to work on those. So section 3.4.5, problem numbers 4, 6, 7, 9, 11 and
345, the first number is 6.
3, 4. Yeah, 3.41. Yeah, I thought they'd be nice and keep the section all the same, but no. 341, the exercises. 341. Set 1.